What's up, everybody? Welcome back to another live stream from Scale It Learning. Today, we are doing something that has been asked about over and over from a lot of followers and subscribers, which is, can you please do a mathematics level 2 test? And so finally, I promised people that today would be the day, and I got it all queued up here. We are doing practice test 1 from the official study guide from the College Board. Now, if you're new to these streams, I'm taking these tests live, and I haven't seen them, so I'm taking them for the first time. I got the first question queued up. I can kind of see that. But in general, I'm doing the whole thing in real time to really give you the authentic test-taking experience. So you can see what I'm doing is actually working in real time within the time frame and when I'm seeing it and processing on the fly. So that's the idea. And that's been really helpful for people as from what I've heard. So we're going to keep on with it. Here we go. We got a calculator because this is a calculator test. They even use a graphing calculator, so I might need to use Desmos. We'll see. And that's it. Without further ado, let's begin. We're going to set a timer. Wait, I don't even know how much time is there for this one. What is the time limit? Hold on. Does it say? I don't even know. Doesn't say at the beginning. This is kind of funny. Should have looked that up before, eh? Yeah, usually it says at the top. Let's see. Let's just Google it. All right, I'm going to check on my phone. How much time for SAT subject math 2? 60 minutes. All right. So it's 60 minutes for 50 questions. Let's get that set up here. Timer. We've got an hour. Let's do this to 60 minutes. And let's see if there's any other comments or anything going here. And by the way, it's really easy to get a 1 hour. Oh, thank you guys. I should have checked there. The cool thing is that this one, to get an 800, I think you can get like 5 or 6 wrong or something like that, something crazy. So we got the timer. We're gonna start in 5, 4, 3, 2, 1. Let's do it. All right, we got xm. Let's combine these. Look, we add the x1, so it's xm plus negative 2m. X to the negative m, or that's the same as 1 over x to the m because it's a negative exponent, and that is b. Right? Yeah. Okay, that is number 1. Number 2, all the following numbers satisfy the inequality except, all right, I'm just going to plug it in. Negative 2 plus 1 is negative 1 times negative 6. What's this one? Because this one would be 1 times negative 5. That works. This would be 3 times negative 4. That's negative. This would be 5 times negative 3. This would be negative 2. Yeah. So it's only negative 1 that doesn't work. For all real numbers m, the equation y equals mx plus 3 represents which of the following in the xy plane? Lines whose x-intercept, no, y-intercept is 3. The slope is not 3. That's the y-intercept. That's the slope. Slope is m. That is it. All right, we don't know what the slope is, but it's all lines like that. Next, we have this equals this. What is the value of a plus b? Okay, check this out. Immediately, I'm going to say 2 to the a equals... Okay, actually, what am I talking about? This is pretty easy. 2 to the 6th power is 64. 4 to the 3rd power is 64. So it's 6 plus 3. A is 6. B is 3. And that is a plus b is 9. I remember this by the fact that for some reason I remember 2 to the 5th is 32, but 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. What is the domain of the function? Okay, so the domain is anything as long as it's all real numbers, because it's anything that as long as the denominator in a fraction doesn't equal 0, we're good. And so since even if you plug in negative 1 here, we're still going to get positive 1. This is not going to zero out because x squared will always be positive. So it's all real numbers. There's no domain restrictions. That's all we're looking for. Negative 0 in the bottom or a negative within a square root as a domain restriction. Next, 2x cubed. So what is the value of y when x equals absolute value of y? So let's plug it in. Boom, boom. So I get 2 times negative 2 cubed plus negative 2 squared. So this is 4. That's negative 8, negative 16. So that's negative 12. And the absolute value of that is positive 12. Next. Numero 7. What is the greatest value of x for which f of x equals 5? All right, well, let's plug in 5 here and set it equal to x. It's 3 squared. Square root both sides. X minus 3 equals square root of 5, positive or negative. But they want the greatest value, so we're going to take the positive. We don't worry about the negative. And then we add 3 to both sides, and that's it. And let's see what it equals. Square root 5. Equals plus 3 equals 5.236. 5.24 is the closest. All right, nice. Number 8. Okay, this is a stem and leaf plot. The stem and leaf plot above shows mathematics scores a national test for our group of high school juniors. What is the median? The median is the middle. So check it out. We find it like this. Cross off 1, cross off 1, 1, 1, 1, 1, 1, 1, and there's the middle value. So it's, I don't know how many scores. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it would be the 6th value is the middle, and it means it's a 56. Because this format means it's a 50. These are all 56, 58, 58. So 56 is that middle or median value. Next, this equals for y of that equal to 0. So we do inside out. So f of x goes into g of x. So it's 1 over, and then we plug in f of x for x. So f of x is this, plug it in there. 1 over 2x plus 1 minus 2. When does this equal to 0? All right, that's the composite function. Now we solve. Add 2 to both sides. 1 over 2x plus 1 equals 2. Multiply both sides by 2x plus 1. 1 equals 4x plus 2. 4x equals negative 1. Divide by 4, x equals negative 1/4. Negativo 1/4. And we could plug it back in. Negative 1/4 into that is negative 1/2 plus that is 1/2 plus that in 1 over 1/2 is 2 minus 2. Yeah, 0. It works. It works. That is me checking it, and now I'm going to go on. Number 10, let a be a non-zero constant. If this equals a, then x squared minus 2, it is a over 2. Because if we divided this by 2 and this by 2, we'd get x squared minus 2 equals a over 2. Pretty straight up. Number of months in business, profit in thousands of dollars. So they've been 0 months, 0. Then 1 month they made 1,000. 2 months they made 4,200. 3 months 9,100. The table above shows the profit made by a new company. Of the following functions, which best models the relationship between the company's profit and the number of months in business? We can plug these in and figure it out. I'm already guessing this is not linear because it's going up by 1, then it's going up by 3, then it's going up by 5 about, then it's going up by 7. So it's not linear. So like these two I'm immediately suspicious of. It's probably one of these. It's probably not x squared. 1 squared, 2 squared is 4. Yeah, it is x squared. 3 squared is 9, 4 squared is 16, 5 squared is 25. So x squared would be the best one in terms of matching those up. Y sub n equals that, where n equals 1, 2, 3. Which of the following statements is true? For all n, y n equals 0. Hold on. Oh, I get it. Let's plug it in. So when n equals 1, it's 1 minus negative 1, which is 2. When n equals 2, it's 1 minus positive 1, which is 0. Then when x so look, it's going to oscillate between 2 and 0. For all n, y equals 0 or y equals 2. And we just figured it out, right? Because then again, when y equals 4, it's 1 minus 1 and it's 0. So it's 0 or 2. I don't know what this is. It doesn't make any sense. Okay. Sorry, I'm tired. Which of the following is not a graph of y as a function of x? It's not a graph of y as a function of x. Oh. Which one's not a function? It's this one. Because it fails the vertical line test. That's it. Wait, what? That is number 13. We need to go to number 14. The figure above shows the xy plane. If f of x equals cx plus 3, g of x equals what? C is less than D, and they're both positive. Which of the following is true about the graphs of f and g? Okay, they're both linear. Interesting. Okay, let's see if I can actually graph these out. So this one has a milder slope, and it's got a y-intercept of 3, like this. Let's pretend it's going this way. And then D is bigger, so D is a steeper slope, and it's down here, y-intercept of 1, and it's probably like going up like this. And they intersect in quadrant 1. Obviously, they do intersect because they don't have the same slope. But yeah, look, that drawing alone, I think I'm pretty confident they intersect in quadrant 1. Okay, next. 8 cars, each of a different color: red, blue, black, gray, white, green, tan, gold, travel one behind the other to a campground. The red car must lead and the green car must be last. So red must lead, green must be last. How many different orderings of the cars are there? Okay, so then there's basically 1, 2, 3, 4, 5. There's 5 spots that are up for grabs because the other 2 have to be set, and it's just 6 spots. Excuse me, 1, 2, 3, 4. So it's just 6 factorial because we'd have all these, and it's like in those middle 6 spots is like we have the first option. There's 6 choices. The second choice, once we've chosen this, there's only 5, and then there's only 4, and so on. And you just multiply them all together, which is what 6 factorial is. Permutation. All right, next. If ln of x equals this, then ln of 2x equals... Wait, hold on. I can't remember how to do this. Wait, this means e to the 1.58 equals x. So then I think I'm just going to use the calculator. I know there's an easy way to do this. All right, I'll just do this. So x equals this, so it'll be like 2. So ln of 2e to the 1.58. Okay. 2e to the 1.58 is 2.273. I just converted this to the exponent because this is sub e, so I know it's e to that equals that. And then I said, all right, well, plug in, if this is x, 2 times this, and take ln of that. That's what it's asking for. So that was my little workaround. Because I know there's an easier way. I just can't remember. You don't even need a calculator, I think, for that. An insect population is growing in such a way that the number in each generation is approximately 1.5 that of the previous generation. If there are 100 insects in the first generation, approximately how many insects will there be in the 4th generation? Second is 150. Third is 225. And then 4th is probably 338, but let's see. Okay, so 225 times 1.5. 338. Okay, next. Which of the following are true? If x does not equal 2, then this. This is not true. X could equal -2. This is true. Because x can't, then x definitely can't be 2 if this is not true. X could be -2. If x squared plus 4 equals 8. No, that's not true because it could be -2. Same thing. So only 2. Only 2, my friends. Next. Note, figure not drawn to scale. In parallelogram ABCD above, AB equals 8. All right, fill in the diagram. AB equals 8 and AD equals 13. If x equals 42 degrees, what is the value of h? We can do a little... Wait a minute. Hold on. Can we do trig here? 8. This is also 8. This is also 13. This is also... Wait, I'm missing something here. Oh, I know what we do. We say tangent of tangent of 42, what am I doing? The 13 is a red herring. Tangent of 42 equals opposite over hypotenuse. H over 8. And then multiply both sides by 8. And it becomes H equals 8 times tan 42. 8 times tangent of 42 degrees equals 7.2. 20. There it is. If f of negative 1 equals negative 3, f of 3 equals 2, and for all real numbers x such that f of x equals ax plus b. All right. So we've got, I am assuming this is it's a linear function. Yeah, that's what it's saying, ax plus b. So we got two coordinates. We got 1, negative 3 for the x, y. And we've got, when x is 3, y is 2. Now we can calculate the slope. So I'll subtract down, right? Negative 3 minus 2. Difference of the y's over the difference of the x's. So that's negative 5 over negative 2, a.k.a. 5 over 2. So we know that the slope a is 5 over 2. So d and e are out. And then this is b, which is the y-intercept. So we can find the y-intercept now by saying y equals 5 halves x plus b. We don't know what that is, but we have some coordinates that we can plug in. So I'll plug in 3 for x, 2 for y. 2 equals 3 times 5 halves is 15 halves plus b. Subtract 15 halves, subtract 15 halves. Then it's 4 halves. I'm turning 2 into 4 halves minus 15 halves equals b. 4 minus 15 is negative 11 halves. So b is negative 11 halves, which is this. Yeah. Okay, keep moving on to 21, which is the value of x. The funny thing, like, I know this is a hard math test, and so I'm like waiting for the questions to get really hard. Like, they're already a little tricky, and like I said, I never look at these ahead of time. But it's definitely harder than the real SAT, than the actual SAT, I think, a little bit. Not as wordy of problems, which is nice, but okay, which of the more advanced? Which value of x in the interval satisfies the equation cosine? Remember, cosine of x, and sorry, secant is 1 over cosine of x. And so secant's literally the inverse. So it's wherever cosine of x equals 1, really. Because 1 equals 1 over 1. I'm trying to remember. Yeah, because cosecant is the inverse of sine. And cosine equals 1 when it's 0. Because cosine of 0 is 1. And that's it. And watch this. Cosine of 0 is 1. And can't do 1 over cosine of 0 is also 1. All right? So it's 0. Next, 22, the function g is defined by this. What is the range of g? So the original range of sine is negative 1 to 1. But in this case, now it's tripled. That's what triples that range. So now it goes from negative 3 to 3. But then it shifts it down by 1. So now it goes from negative 4 to 2. And that's the range. Negative 4 to 2. Yeah. Okay. We're almost at the halfway point. In the first quadrant of the xy plane, the point of intersection of the graph. So this and this is which of the following? I'm allowed to use a graphing calculator, so I could just graph this, to be honest. And why don't I just do that? Let's go to Desmos. We could do it with algebra, to be honest, but we have it. Why not use it, right? So we have x squared. It's a little ellipse. Hey, what happened? Hold on. X squared over 16 plus y squared over 25. X squared over 16 plus y squared over 25 equals, was it 1? And then we have y equals x. And it's right here, 3.123, 3.123. Da-da. 3.12. Beautiful. Beautiful. All right, next. Wait, did I get that right? 16, 25. Yeah. The probability of randomly drawing a piece of red candy from a bag containing only red and purple is 2/3. So 2 out of total 3. Which of the following could be the number of red and the number of purple? Okay. Hold on. Drawing a piece of red. So 2 red. So that means if there's 2 red, there's 1 purple. So it's a 2-to-1 ratio, because then there'd be 2 red and there'd be 2 plus 1, which is a 3 total. All right. So there's double the red than purple. That's this one. Yep. 20 out of 30, 2/3. All right, good. Numero nexto. The table above defines the function f, which has domain 0, 1, 2, 3, 4. What is the value of f of 3? All right, so first of all, what is f of 3? F of 3 is right here, which is 4. And then they want to plug that back into the function for its x value here, which is 2. This is just a little function notation. Next, functions f and g are defined for all real numbers. The function f has 0 is -2, 3, and 7. The function g has 0s at blah, 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 blah. How many distinct zeros does the product of the function? Oh, what? Okay, this is an interesting one. So we have zeros there, and we have zeros there. Is there a rule for this? Hold on. So this would be I'm just going to have to use, I feel like it's 7, but that seems so simple. That seems so easy. Oh, no, because they overlap. I'm going to say 6. I'm going to say 6. Oh, of course it's 6. Distinct zeros. What am I talking about? This is obvious. Yeah, because it would be like x minus 2 times x plus 2, x minus 3, blah, blah, blah. And then we'd have 2 x minus 7s. And then so those would not be distinct, so it's literally 6. Yeah, it's not so bad. I just haven't seen a question like that, but it makes total sense. Okay, now we go to 27, all the way back here. La la la. Just wasting a lot of time. I should just zoom out, but now I'm like in it, and I've done it so long I want to keep going. Okay, next, in the figure above, the diameter of the base of the right circular cone is 8, which means that the radius is 4. What is the volume of the cone? So it's 1/3 pi r squared times height. And we don't have the height. We have the slant height, and that's no good. We want it didn't, so we need this value. So if this is 4 and this is 10, Pythagorean Theorem says 4 squared plus x squared equals 10 squared. 16 plus x squared equals 100. X squared equals 84. X equals square root of 84, which is whatever that is. So then it's 1/3 pi times 4 squared, which is 16, times square root of 84. All right, that's it. So 1/3. Okay, so I'll do the 1/3 at the end. I'll divide by 3. So it's pi times 16 times square root of 84, and then we divide it by 3, and it's 153. It's this guy. In the xy plane, what is the distance between points whose coordinates are that and that distance formula? So we say square root okay, let's just plug it into the calculator. So it's difference of these guys squared plus the difference of these guys squared. So 2 square root 3 minus square root 3. Square root 3 is what? Is that? So it's square root 3. Actually, wait, let's do it this way. It's this what am I doing? That's negative. So 2 square root 3 minus negative square root 3 is actually 3 square root 3 squared, plus this minus this is negative 3 square root 5 squared. This becomes 9 times 3 is 27. Plus 9 times 5 is 45. And that's 65, 72. So it's the square root of 72. Oops. Which is 8.48. 8.49. Okay. Okay, let's move it on. 29, isosceles triangle. Isosceles has a base length of 25 and a vertex angle 50. So then these are isosceles, so these two are equal. If that's 50, 130, 130, so that's 65 degrees, because these have to all add up to 80. What is the perimeter of a triangle? I think we have to use trig for this. Okay, so I'm going to draw an altitude down. Is there a better way for this? Hold on. Oh, yeah, we could use the law of sines. So check it out. The law of sines says sine of 50 over 25, sine of this over opposite equals sine of 65 over x, which would be either of those sides. Then we say sine of 50 over, all right, let's cross multiply. We get x sine of 50 equals 25 sine of 65. And then we divide both sides by sine of 50. And we get our x value. So 25 times sine of 65. 25 times sine of 65 equals that divided by sine of 50. Divided by sine of 50. And again, this just gives me the side length of 29.57. And that's this side is also 29.57. So it's 29 plus 29. So that times 2, because there's 2 of those, plus the other side, which is 25, equals a perimeter of 84.15. 84.2. Wonderful. A taxi charges a base fee of $1.25 plus 75 per each mile. Okay. Or part thereof. Which of the following would represent the taxi fare for a trip of length X miles? This is the least integer that is greater than or equal to X. Okay, so look, we would say a base fee of 125 plus 0.75, and then again times this weird little symbol. Because then it would be like, hey, if we've gone half a mile, it would represent 1, and then it would be 0.75. 1.3 miles, it'd actually round up to 2. I think this is it. It's a pretty simple question. Unless I'm missing something, it's a pretty easy problem. It's just 125, which is the base, plus this is the slope. Now, should it be x plus 1? Let's see. Base fee plus 75 for each mile. I don't see why it would be x plus 1, because it doesn't say it charges $1.25 for the first, or I don't know. The x plus 1 actually makes no sense to me, so I'm leaving it there. Next, we have this, then f of x equals this, f of x negative y equals, so wherever we have y, it's the same thing. It's the same thing. It's this one. Because if you're plugging in a negative y and you're squaring it, what does it matter? It still becomes positive y squared, positive y squared. Nothing cancels out, nothing changes, because it'd be like sort of within parentheses. So it's irrelevant. It's the same. 32. I think I'm doing pretty good on time because I'm more than halfway done. I got more than half the time, but the question could start getting really hard now. 27 identical cubes are arranged to form a larger cube. The diagonal of each face of each of the 27 identical cubes. This is weird. This is a weird problem already, I'm thinking. 27 identical cubes. Ta-da. Ta-da. And this. Okay. So this is made up of 27 identical cubes. Actually, I can already tell you, look, watch this. Visually, we can be like, I already know what this is going to look like. Because 27 means it's going to be split up like this. You see what I'm saying? And then if I brought it back, you'll see what I mean. It's like a Rubik's Cube, basically. I don't know if I need to do all this drawing, but... Okay, there it is, 27 identical cubes. And then the diagonal of each face of the 27 identical cubes measures. So it's like this is, I'll just write in here, 1.415 centimeters. What is the volume of the larger cube? Okay. This is kind of weird. I think I can figure this out. So it's saying like of this little guy. Oh, this is actually pretty easy. I didn't need to draw this. So we can just say if the diagonal is 1.415, this is x and x. So we can use the Pythagorean theorem. X squared plus x squared equals 1.415 squared. Then 2x squared equals 2.00. Divide by 2, divide by 2. X squared equals 1.011125. And then take the square root. And we get 1.0005. So basically it's 1. So the volume of this cube is 1 times 1 times 1. So one of these is 1. And then there's 27 of them, so it's this. It's funny. That's a really random problem. Okay. In the list above, t is an integer. For the list, if the mean is equal to the median and the range is less than 10. So the range is less than 10. What is the value of t? So 4 to 12, and the range is less than 10. So it's 4, 5, 8, 12. And t can't be 2. Right now, here as it is, the median would be 6.5. If this is where the middle values were. This would be if t is 3. But then so 6.5. So as long as it's like not between 5 and 8. Let's see. How do I figure this out? Actually, this is kind of tricky. No, I don't know. Kind of confused because then if it comes on this side, then here or here, it's only if the nut t isn't here that it throws off the median. So let's just assume it's not there. All right. So let's say the median is 6.5. So then it's like t plus all of this stuff divided by 6 has to equal 6.5. Let's see if we can find that value. So 8 plus 5 is 17, 27, 29, 37. So t plus 37. Okay, multiply both sides by t. T plus 37 equals 36 plus 3 is 39. Subtract 37, t equals 2. But t can't equal 2 because the range has to be less than 10. So then I already know that it's got to be between 5 and 8. Because if it's 8, or 8 would work too. Because if it's 8, then, here, let's move this. Hold on. So it can't be 2 because it's got to be less than 10. If it's actually 6.5, this would be a problem because then the median wouldn't be 6.5. The median would be something above it because it'd be in between 6.5 and 8. If it's 8, then the median would be 8. Hold on. So 4 plus 5 is 9. Plus 3 eighths, which is 24, is 33. 43, 45. Divided by 6. I don't think 8 works either. If it's 11, then it goes back to 6. It can't be 11 because now it goes back to a median of... Oh, no, it doesn't. Yeah, 11 would be a median of 8. And then it'd be, hold on, 16, 26, 27, 37, 39, 48. Yes, it's 11. 11 would give me a mean of 8 and a median of 8. Oh my God, that was pretty hard. Okay, which of the following are polar coordinates of a point with graph r equals cosine theta? Darn it, I don't remember polar coordinates. Okay, which of the following are polar coordinates of a point on the graph of r equals? Oh, wait, I can use Desmos. Polar. How do I switch to polar? I know I can switch to polar coordinates somehow. Wait a minute. Desmos polar coordinates. All right, let's see this. I know you can go polar on your graphing calculator, I believe. What is all this nonsense? Get rid of that. Okay. So it's r equals cosine of theta. R equals cosine, let's say x. Wait, is this not polar coordinates? I know what this is not polar coordinates. Oh, here we go. R equals cosine of theta. No. It's still giving me this thing. So I guess, hold on a second here. Oh, maybe it just goes into polar. I don't know. Okay, so anyways, hold on, let me try. I can't remember coordinate that well, polar that well. I'll look it up afterwards. But R equals cosine of theta, and it would be like, I remember the R value is like the distance out, and then the theta is like the angle or something. So 1 and pi halves. Let's see. Oh man, I really don't remember this. I might just guess and then come back. Cosine. Okay, I'm just gonna use regular coordinates where, like, I know at pi halves, this thing is not equal to 1. It's at 0. It's equal to 1. At 0.5, is it 5 pi thirds? Hold on. Hold on. 0.5 is about. Okay, I'm going to go with 0.5 pi thirds. I don't know why. Let's just roll with that because it's coming down. I don't know. We'll see if it's right. I'm feeling like, because that would be the x and y sort of coordinates of cosine. So I'm thinking maybe it's the same deal. But we'll look into it. All right, prime factorization of a positive integer n is p to the third. Okay, so n is some, like, there's some integer, like if p would be 3, n would be 27. It'd be 3 times 3 times 3. Okay, which of the following is true? No, because p could be even. If p is 2, n would be 8, so it could be even. N is only one positive prime factor. Yeah, that's true, because that's what this means. The positive prime factor is p. It's, because they're saying that's it. N has exactly 3 distinct factors. No, it has 1. It's just p times p times p. It's only 2. It's weird. Question. Okay, next, in the xy plane, the asymptotes of a hyperbola are aligned x equals 5 and x equals this. What are the coordinates of the center? All right, so check this out. I'm going to actually graph it. Y equals x plus 5. I don't know if this is the best way to do it, but x plus 5. Y equals negative x minus 5. So here's the thing. Here's the coordinates, and then I don't know. Hold on. Oh, the center are just where they cross. It doesn't matter if it's going this way or this way. The center is here. It's negative 5, 0. That's it. It was pretty easy once we graphed it, I mean. Okay, test number, student score, class mean. Okay, the table above shows a student's record of performance on 5 tests. On which test did the student... On which test did the student rank the highest in relation to other students in the class? Do we have to use the standard deviation? All right, so it's 3. So this person ranked 9 up. So 3 standard deviations above. This one ranked below, so obviously 2 is out. This one ranked 6 above, but that's 1.5 standard deviations above. This one is 8 above, which is not like basically 1 1/3 standard deviations above. Because standard deviation is like, then you go into another section if you're 6 above, and then this one is 5, so this would be 2 standard deviations above. But so I would say that it's 1, and they're trying to trick you and say that it's 5, because 5 they went 10 points up. Here they only went 9 points up, but here the standard deviation is 5, so that's 2 standard deviations above the mean. Here they're 3 standard deviations above. So I'm rolling with 1. Assuming I interpreted that correctly, I think I got it right, but we'll see. When a positive integer n is divided by 4, the remainder is 3. Okay. Which of the following could equal n for some integer t? So it would be 4n plus 3. Oh, it's not there. Oh, it's 4. It's divided by. Could equal n for. Oh, some integer t. I'm sorry. It's 4t minus 1. It's c. Okay, here's why. I'll just give you an example. Let's take 10, for example, okay? 10 would be t. So this one would be 40 minus 1 is 39. Divide by 4, and we get 9, 36, remainder 3. Okay, any of these other ones wouldn't work. Like, otherwise this would be 42 divided by 4 is 10, remainder 2. This would be exactly no remainder. This would be a remainder of 2, and this would be a remainder of 1. Because it'd be like 37 divided by 4. Okay. Next is this one. The figure above, O is the center of the circle with the radius 1. So this value is 1. This value is 1. And line CD is tangent to the circle. So here's, we got a right angle and a right angle. Circle with a radius of 1, and line C is tangent to the circle at A. If the measure of AOC is 30, and the length of CD is 3, what is the length of BD? All right, so we've got quite a lot to work with here. So this is a right angle. This is a 60-degree angle. This is a 30, 60, 90. We know that this side is 1. We need to get this length. No, we already have this length. We need to get this length, I guess. So this is a length of 2, and then we can use Pythagorean Theorem. Now let's find this length, because we'll subtract it from 3 to get this length. So if this is 1, right, it's this side. Let's call this x. X times square root of 3 equals that side. So divide by square root of 3. Divide by square root of 3. So x equals 1 over square root of 3, or square root of 3 over 3. So this side is square root 3 over 3, which means this side here is 3 minus square root 3 over 3. And then we use Pythagorean Theorem. 2 squared plus that squared equals c squared, because we want BD. So 3, let's see what 3 minus root 3 over 3 is. Square root of 3 is, divided by 3 is, and then 3 minus that. 3 minus 2 equals that. So it's that squared plus 4, 2 squared, is c squared. And then we take the square root of this answer to get c. We get 3.14. It looks like pi. That's funny, 3.141. That's interesting. Okay, next, 40. 11 problems to go. Okay, if f(x) equals this, f of x is less than 0 when x equals 1.27. F of x is greater than 0. So it's some like random, this is an exponential function, e to the x, so it's going to go like this. And it's saying that n plus x. So x equal, so when x is 1.27, .28, and then it's positive here, so it's like somewhere in here. It's probably crossing over like that, which is line could be the value of k. I think we need to graph this. I have no idea. So we have all these different values between negative 4.7 and 4.9. All right. So ex plus x. Ex plus x. Okay, so right now it's totally wrong, and then it's minus. Let's try the first one, 4.7. So basically what they're saying is the 0 has to occur between 1.27 and 1.28. So that's what the first option A, negative 4.7. And it's occurring at Nope, 1.24. It needs to be above 1.27. Now let's try 4.75. Nope. 4.8. Almost. Yep, there it is. And then probably 9 would be too big. Yep, it's beyond 1.28. So it's 4.85. Okay, good job. To myself, I'm saying that. That's funny. All right, next, 41 is in the graphs above. Graph 1 shows a portion of this guy, sine, this, where A, B, and C and D are constants. Graph 2 could result from changing which of the constants is f of theta. All right, let's see what they did here. The range hasn't changed, so A will be the same. Let's see, A, B, C, D. Looks like the period hasn't shifted, so that means, I mean, the period hasn't changed, like it hasn't stretched, so B hasn't changed. D, it hasn't moved up and down, so D, it would be C. It's probably some shift with C, because you see how it's like moved, kind of. It's a phase shift, which is usually C. Hold on, A and D. A and D wouldn't even make any sense. So it's C only. Oops. All right, next, the number of birds on each of islands X and Y, remains constant year to year. However, birds migrate between the islands. After 1 year, 20% of birds on X have migrated to Y, and 15% of birds on Y have migrated to X. Okay. So this is the new Y, and this is the new X. If the total number of birds is 14,000, how many birds are on island X? Okay. The number of birds on each island of each island. So they remain constant, however, the birds. Oh, I get it. So it's like the numbers remain, so it's like this. It's like 0.2x plus y equals point. So it remains constant. Oh, I get it. So 0.2x plus y minus 0.15y equals y. Oh, I see. So then 0.2x equals 0.15y. That's how we can do the substitution. Okay, got it. Now it says that the total number of birds is 14,000. How many birds are on island X? So again, on island X, we've got, I think I did this right. Island X, okay, so 0.15y plus X plus 0.2x plus y equals 14,000. And then we're going to substitute in, let's solve for x. 0.15y equals 0.2x. So then this is 0.2x plus x plus 0.2x plus divide by 0.15. And then it's 0.2 over 0.15. X equals 14,000. I think this is going to work. So then we say 1.4x plus 20 over 15, which is 4/3 x, is 14,000. So then it's, let's see, 1.4, so it's 14, 1.4 over 1, 4.2 over 3. So 8.2 over 3x equals 14,000. So then multiply this by 3 over 8.2, the reciprocal, 14,000 times 14,000 equals, so x equaled 5,121.95. So that was what x started with, and then the total number. Oh shoot! Wait, this didn't work. I got the wrong answer. Hold on. So however, okay. So the number of each island remains constant. Number of birds on each. 20% of the birds on X have migrated to Y, and 50% of the birds have migrated to X. So that makes sense because it's like 6,000. Okay, so if X is 6,000 and Y is 8,000, so 20% of 20. Oh shoot, I'm running out of time. 20% of 8,000. Oh, it's just like this. Yeah, so 0.2 of X equals 0.15 of Y. So X obviously has to be smaller. So X can't be 8,000. It can't be, it's either one of these two. So it's probably 6,708. Because look, 20% of X would be 1,200. 15.15 times 8,000. It's 1,200. No, it's this. It's 6,000. This is where 0.2 and 0.15 Y are the same. I don't know what I did here. I must have made some mistake. 1.4x, 20 thirds. 1.4, then I did 4.2. 3, I have no idea what I did. 8.2 over 3. Yeah, I don't know. It's okay. Whatever I did, I messed up, but I think I got the right answer. All right, next we've got this one. If z equals 1 minus I, which of the points in the figure above is the graphical representation of z squared? So that is 1, this would be times 1 minus I, minus 2I plus I squared. I squared is negative 1. 1 minus 2 is 1. These cancel out. So it's negative 2I. And there's no real, it's B. Negative 2I. There's no whole number part, or like real number part. What is the total surface area of a right circular cylinder? All right, so a right circular cylinder. What is the total surface area if the diameter of its base is 2r, which means the radius is r, and the height is 2r? Okay, so to get the surface area, it's the areas of the top and bottom circles, whatever. So which is just pi r squared, which is nice, and there's 2 of them. So 2 pi r squared plus the this is actually just like the formula. This is crazy. Plus the circumference, which is 2 pi r, times the height, which is r. So then it's 2 pi r squared plus 2 pi r squared, which is 4 pi r squared. And it's not an answer. Oh, shoot. Okay, hold on. Pi r squared. The diameter of its base is 2r, and its height is 2. Oh, 2r. Oh, shoot. Darn it. So there's a 2 in there. So it's 2 pi r squared plus 4 pi r squared, which is 6 pi r squared. Good thing they didn't have that as an answer, because I would have gotten that wrong. That's bad. Next, 45. If the terminal side of an angle theta in standard position lies in quadrant 4, so like an angle like this, I guess. So it'd be like like that. Which of the following must be true? Okay, so that means we're here, and the way it goes is everything is positive here. It's like this. Everything is positive here, sine's positive here, tangent's positive here, cosine's positive here. Okay, so, and these are just the inverses, so it's the same thing. Cosecant, so we're in quadrant 4. Cosecant is negative, which is sine, which is true. And secant is positive, which is true. I think it's A, actually, to be honest, because it's just inverses of the two functions, but I think it's right. Cosecant is definitely negative. This is wrong. Tangent is not positive. It's only positive in quadrant 3. Tangent is negative, and cosecant is not positive. Sine is not good there. And then sine is not positive. Okay, good. That's it. A ball is tossed into the air, and the height of the ball above the ground at different times are recorded in the table above. Okay, it's here, it's here, here, it's here, here, it's here. All right. A quadratic regression equation is obtained for these data with height expressed as a function of time. According to the regression equation, what is the maximum height of the ball? Do I actually have to do that? Oh, shoot. I think we might have to know how to do a quadratic regression in your calculator, which I don't know how to do in the TI-84s. I don't even have a TI-84 here. But I can see that it's probably going to be around here somewhere. How do you do a regression in Desmos? Let's see. Quadratic regression Desmos. Otherwise, I'd be totally guessing. I don't know. Oh, wait. Maybe this will work. Okay. So we've got 0, 5.517. 0, 5.517. 1.5, 20.5. And 2, 11.9. And then the rest of these I don't want. I don't know how to get rid of them like this. All right, we've done it. Oh, shoot. Oh, there it is. There it is, the max height, which is 22.4. I think that's it. I don't know. Not really sure. Let's just roll with it. Yeah, I think that's the vertex. 22.4. All right, 5 minutes left, and we got 4 problems. All right, in the right triangle ABC, the measure of A is 90. Okay, so here's A. B and C. AB is 3. BC is X. If sine C equals K, sine of C equals K, it's 3, then 3 over X equals K. Then in terms of K, sine of C equals, no, sorry, X and 3 over X. Yeah, that's right. So 3 over X equals K. Then in terms of K, AC equals, okay, and then we can say this is 3 squared, X, this side is X squared minus 3 squared, because it's hypotenuse minus that and the square root of that. And then we know that now we can plug in K. Okay, so now isolate. So 3 over K actually also equals X. Plug this in here, and it's square root of 9 over K squared minus 9. It's this one. Yeah. Can maybe finish. Fx equals this. What is the value of f of 4.7? So we plug it in here, and it's 4.7, which is then 3.7. And then 3.7, it goes back in here. 2.7. 2.7 goes back in here. 1.7. 1.7 goes back in here, and it's 0.7. I don't know if I explained that well, but I think that's what it is. It's like a weird, that was a weird function. Okay, next, 2 questions left. How many non-congruent triangles ABC exist such that the measures of A is 42, A is 42, AB is 6, and BC is 4. I really don't know, but angle side side tells me that it's definitely not 1. It's definitely not none. I don't think it's none anyways. I don't see why this couldn't exist. So 42. The thing is, it's like I could do another one like this. Oh, I see what it is. I see why it's limited now. I think it's 2. I think I just have a feeling from geometry. I don't know if that's right. It's kind of a guess. I think you can set this up another way with C coming out. I don't know. I just think you can do it another way. Okay. It's like that. There's something in geometry where you can have 2 triangles. Okay, last one. A magazine article described the growth of a computer network as exponential. The article said that in 10 years, the number of users had risen from 1 million to 20 million. Assuming that this article is correct, in how many years would the number of users increase from 20 to 200? So it goes up by a factor of 20 in 10 years. Oh, shoot. I think we need to... So I think it's 1 million times x to the 10 equals 20. So x to the 10 power, and then the 10th root of, hold on, I don't know how to do. Then we take log of 20 equals log of x, hold on, 10th root of, let me see if I can do this really quickly. 20 to the 0.1 power. 10th root is basically 1.349 times 1 to equal 200. And then, oh shoot, I'm gonna run out of time. So then we'd have to solve log of 200 equals x log of 1.349. We divide by 3.49. Almost made it. Okay, then divide log of 200. I think this is how you do it. Divide log 100 divided by log of second answer equals 17. So that means x equals 17 years. 17.686 years. But that's to go from 1 to 200 million. So 20 million has always been 10, so it's like 7.68 or 8. All right. I think that's the answer because it's already gone 10 years, so it's not 18, it's 8. All right. Who's still here with me? All right, we got a few people. Please do an acuplacer. I gave you the link a couple times. All right, do you plan on doing SAT? Yeah, I'm definitely doing SAT. Okay, let me check my answers, guys, real quick. Make sure this is not like the SAT for me where I'm doing this all the time. I don't do this nearly as much, so let's make sure I got everything right. There's a quick answer grid. Hold on. I don't want the explanation. So here we go. Okay, let's do it. So we've got here, and even with 50 questions only in an hour, I didn't finish in time. I almost did, but it was close. I couldn't do it. All right, let's do the answers. B A B C E, B A B C E. Then I've got 6 is C E D B B. 11 is CBEAA. And then 16 is BABAB. BAB. Oh, shoot. What? 19 wrong? Dang it. All right, I got 19 wrong. Darn it, I was so confident on 19. Wait a minute. X equals 42. What is the value of h? So I said tangent of 42. Why did I say tangent? It's obviously sine. What's wrong with me? Can you see that? Because it's opposite over hypotenuse. What? Should use sine of 42 equals h over 8. So it's 8 times sine of 42. 8 times sine of, 42, which is 5.35, which is a. Darn it. That was so terrible. I knew that one. But okay, there you go. Silly mistake. Got to be careful. So an early one like that, you'd want to be really careful on the real thing. That's I wouldn't want to miss something like that where I knew what I was doing, right? 21 CAABC. CAABC. Okay, 26 CAEDB. AEDB. 31 is EDDBB. EDDB. B. 36 BACDD. BACD. Okay, looking good. I think I got that polar coordinate one right? No, not yet, maybe. Yeah, I did. I got the polar coordinate one right. So we got to look back at 34 and see, make sure how to do that, explain how to do that. 41 is CBBDA. CBBDA. Okay, and these last 5 were the hardest, I think. Okay, 46 is DECAE. A. Oops, wrong. Yeah, this one I really didn't know how to do. E. I kind of guessed. So they said none. No triangles will be possible. 49. So I got 2 wrong. I'll check the curve in a second. 49 is 42. I wonder why they're saying that's impossible. I have no idea. Okay, let's look at the explanations. So, oh, no. 49. No, 49. Choice A is correct, so none. So it says, oh, shoot, that's smart. So I should have done that. I should have thought of that using, I wish they would have said, hint, use the law of sines. Because then we could have just, using the law of sines, you can disprove this, that a triangle is even possible. So you'd say sine of 42 over 4 equals sine of whatever this angle is, C, over 6. And then you'd cross multiply, and sine of 42 over 4. I just wouldn't think of this to do this. You know what I'm saying? Equals 0.1672. Sine of x over 6, and then you multiply both sides by 6. Multiply this by 6, and you get something a little bit more than 1. They're saying that then you would see that this is like, what, 1.0036? You can see that this is impossible in this case because sine of x is never supposed to go above 1, right, in our angle oscillation. So you're like, oh, well, then this is an impossible angle. It's an impossible triangle. I don't know. I wouldn't have thought to do that. I thought this was one of those triangles where you can do like 2 versions of it. I remember that from geometry, but it's wrong. And then the last one was the polar coordinates 34. Hey, yo, Card Trick Kid, what's up, man? How's your summer been? How are you doing? 36. Hey, what's up, Miriam? You're loving the all caps. Okay. Where's that polar coordinate one, eh? Hold on. Was it 34? 34. Nation would be r theta. Every point in the graph of the polar equation r equals cosine theta must have polar coordinates cosine theta theta. Yeah, it's kind of the way that I interpreted it. I guessed and I got lucky, where the x value is the cosine of theta value, which is the 0.5, and then the y value is like what you'd be plugging in. So like I had a notion that it was reversed, but I couldn't remember. So my logic proved to be correct, even though I didn't really know what I was talking about, because I haven't done polar coordinates in a long time. All right, let me see. How do you think it would take to prepare for the math? Okay. Is this math? Yeah, it's harder in the sense like it's more complex. It's higher level. I actually think in ways it's easier because there's not as many crazy tricks and word problems and multi-part problems and all that. Hey man, you're very welcome, Sean. I'm happy. Yeah, you love caps. Okay, so look, I said I've been doing this. I would do one of these for a long time. It's a long time coming. Sorry it took so long. I finally did it. Hope you guys enjoyed it. Let me just check this curve because I know the curve is pretty chill on this test, and I want to show it to you guys real quick. Like I'm pretty sure, even though I got all those wrong, it's probably an 800. Okay, here we go. So yeah, so my raw score would be a 48 out of 800. I don't know if you can see this. Can you even see it if I hold it up like that? So there's the grid, and you can see over here, right? 48 is still an 800. Actually, I could have gotten 7 wrong and still gotten an 800. So it's a pretty generous curve. And I mean, if you know this stuff, I think it'd be pretty cool. Yeah, hey, Eric, thank you. That's my whole philosophy. That's why I do this, because I had a notion that this would be helpful, and people have been really liking it. So, listen, for the upcoming SAT, yeah, I'm going to do an entire cram week. It's going to be crazy. I'll probably do 6 days straight. We're going to go hardcore. I want to get you guys ready and primed to crush the August SAT. Thank you guys so much for joining. If you like this video, please click the like button down below. And also leave comments, questions in the comment section if you have them.